Hello everyone, this is a presentation for storage as a service integration for the Co5 Alkahest framework. In this, using the ES and the base statement, we are able to extend the storage, extend the obligations for the storage, Filecoin storage. Along with that, the interface for the arbitrator have been extended to the file storage arbitrator. Alongside these two contracts, there are additional two utility contracts. Those are the Filecoin storage oracle and the Filecoin deal creator. And using this whole storage as a service, we can now interact with the external systems like the Filecoin network, and we can also send data from the Filecoin storage oracle to the offshore oracle for verification purposes. Also, we can use the Filecoin deal creator as a contract for creating deals with other users. In this, we have added three functionalities. Those are the Filecoin storage obligation. This is a contract that creates storage commitments and attestations as attestations. Contract serves as a foundation for representing storage agreements on-chain verification. It defines terms of storage including data CID, size, replication factor, renewable period of requirements, geographic location preferences, and Filecoin deal IDs. This component serves as a foundation for representing storage agreements in a verifiable on-chain way. Then there is the Filecoin storage arbitrator. Implementation of the iArbitrator interface that validates whether the storage commitments were fulfilled or not. It checks if the providers are storing the data, if the proofs are recent enough, if the geographical requirements are satisfied, if the parameters like storage size and duration meets the requirement. The arbitrator enables conditional validation of storage obligations to determine if they are being properly maintained. And lastly, the Filecoin storage oracle. This oracle brings the coin storage on chain in a way that can be verified by smart contracts. It allows authorized oracles to submit verified storage proofs, tracks which providers are storing which CIDs, maintains proof history with timestamps and expirations, provides verifications APIs for other contracts. The oracle bridges the gap between the Filecoin's off-chain proofs and on-chain verification. Now I have implemented few test cases using which we can check the actual functionality of these implemented contracts. So first, let's run the test for the Filecoin storage arbitrator. After that, let's run a test for the obligations. And lastly, the test for the deal creator. To summarize what this test do is, the Filecoin storage obligation test provides the functionality of validating that the storage commitments can be properly created and represented on chain, tests that commitment parameters are correctly stored, verifies that revisions to storage commitments work properly, test access control to ensure only authorized parties can modify commitments, verifies demand matching logic for checking if the statement fulfills requirements. Then the Filecoin storage arbitrator test does the functionality of test that the arbitrator's ability to validate storage commitments against requirements, verifies that proofs must meet freshness requirements, how recently they must be, test rejections of commitments with insufficient provider proofs, ensures location requirements are properly enforced, validates that expired or revoked attestations are rejected. Then lastly, the Filecoin deal creator test test that test the creation of deal proposals based on storage commitments, verifies that deal IDs can be recorded back into storage obligations, and test access controls for deal creation management, ensures the proper workflow from obligation to actual Filecoin deal. This is the submission for my project.